Hello and welcome to part 1, Data Preprocessing. So I had to start with this part because this is a crucial step in the journey of making a machine learning model. If there is no data preprocessing, your machine learning model won't work properly. So it's like preparing a journey. Imagine you are about to go for a long journey. Well, you have to prepare your itinerary, book your flights, book your hotels, and pack your luggage. That's definitely the boring part before the trip, but then when everything is well prepared and you're ready to go, your trip might be amazing. Well, it's the same for our machine learning journey. We have to prepare some stuff in order to make sure that we build our machine learning models without any issues. And the stuff that we need to prepare for our machine learning trip happens to be data preprocessing. So I have to be honest with you, this is the boring part, but we are only doing this so that we get the maximum fun later in this course when we make all the machine learning models. So trust me, we have to do it because if we don't do it, we will miss out on all the fun of machine learning. So I did the best I could to gather in this part all the essentials of data preprocessing, and even if I made sure to make it as simple as possible, there is all you need to know about data preprocessing. There is all you need to know how to do to prepare any dataset for any machine learning model. So excluding this one, there are going to be 8 tutorials in this part. So hold on to them, and I promise you that we will get a lot of fun once we start our machine learning journey. Okay, we are almost ready to begin our journey of data preprocessing, but first we need to get the dataset. So that's what we're going to do in this tutorial. So let's do this right now. And here it is. Just gonna put the column titles in bold. Okay, that's the dataset. So what is this dataset about? This dataset contains 4 columns: country, age, salary, and purchased, and 10 lines, 10 observations. And basically this contains informations of customers of some company, and the first 3 columns are informations of these customers like the country, the age, and the salary. And the 4th column, purchased here, tells if yes or no the customer bought the product of the company. So we have to distinguish something very important here that we will distinguish for the rest of the course. It's the difference between the independent variables and the dependent variables. So the independent variables are the first 3 columns, country, age, and salary, and the dependent variable is purchased here, the 4th column. And in any machine learning model, we're going to use some independent variables to predict a dependent variable. So that means here that with these 3 first columns, these 3 independent variables, we are going to predict if yes or no the customer purchased a product. Okay, so that's the first distinction that we really need to understand, and it's very important to do this section because the data preprocessing steps that we're going to do in this section, we will have to do it for all the machine learning models we are going to make. So it's really essential to know how to manage this, but don't worry, it's going to be very simple, and besides, I'm going to give you at the end of this section a template that will allow us later to preprocess the data in a flashlight for all the machine learning models we're going to make. In this one, we're going to learn how to import the dataset. Okay, so here I am on R, and as for Python, we need to set the working directory. So to do this, we have to go to Files here. Here I'm on my desktop. So let's go to our folder Data Preprocessing Part 1. Here it is, Section 2. And this is the right folder that contains the dataset data.csv. So this is the folder that you want to choose to set as working directory. And now to set this working directory on R, you need to do one more thing. You need to click on this More button here and click on Set as Working Directory. And here it is. Now we know that this is the right working directory and we are ready to start importing the dataset. Okay, so to do this in R, what we need to do is very simple. We will just need one line of code. So as in Python, we're going to call it dataset. So that's the variable that will be the dataset itself. And now to import a dataset is very easy. You need to type read.csv, and then in parentheses, you just type the name of your dataset in quotes. So here you have to type data.csv. And that's it. That's all you need to do. So now we're going to select this line of code and execute. Okay, so let's have a look at our dataset. To do this, you just need to click here on the dataset, and it just displays here. Okay, so we have our 4 columns: country, age, salary, purchased, and our 10 observations. And what's interesting to see here is that unlike Python indexes don't start at 0 but at 1, so that's why the first observation starts at 1 here and ends at 10. So that's the second distinction you have to understand between Python and R. Of course, you don't have to program on both. You can choose the one you prefer. But if you want to program on both, as I usually do, it's good to have this distinction in mind. Okay, so we have our data set. It's all fine. And as I just said, here we don't have to make the distinction between a matrix of features and a dependent variable vector. And this will make perfect sense for you as we go along with this part 1 data preprocessing. You'll perfectly understand why in the next tutorials. Okay, so that's it for the importing the dataset step of the data preprocessing phase. So that's it for this tutorial. I look forward to seeing you in the next one, which will be to learn how to take care of missing data. Because sometimes your dataset will contain missing data and you have to take care of this. Now we are finally going to start preparing the data so that our machine learning models run correctly. And the first problem that we have to deal with is the case where you have some missing data in your dataset. And that happens quite a lot actually in real life, so you have to get the trick to handle this problem and make it all good for your machine learning model to run correctly. So let's have a look at the dataset. Here I'm going to my Google Sheets tab. Okay, so here is the dataset. And as you can see, there is two missing data. There is one missing data in the age column here for Spain, and one missing data in the salary column for Germany. So how can we handle this problem? Well, a first idea is to remove the lines, the observations, where there is some missing data. So what we could do is to remove this line and remove this line. But that can be quite dangerous because imagine this dataset contains crucial information. It would be quite dangerous to remove an observation. So we need to figure out a better idea to handle this problem. And another idea, and that's actually the most common idea to handle missing data, is to take the mean of the columns. So here, we are going to replace this missing data here by the mean of all the values in the column age. And that's the same for every feature that contains missing data. We replace this missing data by the mean of the values in the column that contains this missing data. Okay, so let's do this. First, we need to take our dataset. So dataset. Let's start by taking care of the missing value in the age column. So here we will need to take the age column, and to do this in R, we need to add a $sign here, and here we choose age. So by doing that, dataset $age, we're taking the column age of the dataset. Then we're going to add equals, and then we're going to add an if-else. So I'm going to type if-else here, then parenthesis. In the if-else function, you have to input 3 parameters. The first parameter is your condition, if condition. The second parameter is the value you want to input if the condition is true, and the second parameter is the value you want to input if the condition is false. So let's first input the condition. The condition is going to be is.na, parenthesis, dataset $age. And that's it. Is.na is a function that tells if the value in the function is missing or not. So by putting is.na dataset $age, we are checking to see if all the values in the column age are missing. So this will return true if the value in the column age is missing, and false if the value in the column age is not missing. Okay, so that's the condition. And now, the second parameter is the value that is going to be returned if the condition above is true. And of course, if the condition is true, that means that there is a missing value, and that means that we have to replace it with the average. So here we're going to input as the second parameter the average of the column age. Okay, and to compute the average in R, there is a simple way. We can type AVE, then dataset, $age, because we want to take the column age, then comma. And then here we're going to add a function. So we're going to type fun in capitals, fun equals, then function x. This is still part of the R syntax. We're just making a function here, which is going to be the mean function. And then we have to specify what this function will be. And so this function is, of course, the mean, which is an existing function in R. So here, parenthesis, x, comma. And here we're just going to add na.rm equals true. And that means that we ask R to include the missing values when R will go through the whole column age to compute the mean of the values. Now we still need to close the parenthesis here, okay, and then comma. So that's it for the second parameter. And now we need to add the third parameter. And in your opinion, what is it going to be? Well, this third parameter is the value you want to return if the first condition is not true. That means that the value in the column age is not missing. So that means that the value exists. So here we're simply going to put dataset age. Okay, and that's done. By typing this, we replace the missing value in the column age by the mean of the column age itself. So let's select this and let's see what happens. So Command and Control plus Enter to execute. And here it is. It executed properly. And now let's look at our dataset by clicking on this tab here. And good, perfect. The missing value that was here in the age column was replaced by the mean of the column. Great. So now let's do the same for the salary. So we're just going to copy this, paste, and we're just going to replace age by the salary here, here as well, and also here. Great. And now we have to be careful with something. It has to be aligned here. So we just have to do this, and same for here, this. Okay, and now we're fine. Now we're ready to select this code section here, press Command and Control plus Enter to execute. Here it is. Let's check our data set. And perfect, the missing value in the salary that was here was replaced by the mean of the salary column, $63,777. Okay, so we are halfway our data preprocessing phase. We learned how to import the libraries, to import the data set. We learned how to take care of missing data. And today we're going to learn how to encode categorical data. So the first thing that we're going to do is that we are going to explain why we need to do this. So I'm going to go to Google Sheets here to find my data set. And in this data set, we can see that we have two categorical variables. We have the country variable here and the purchase variable. These two variables are categorical variables because simply they contain categories. Here, the country contains three categories. It's France, Spain, and Germany. And the purchase variable contains two categories, yes and no. So that's why they're called categorical variables. And now you can guess that since machine learning models are based on mathematical equations, you can intuitively understand that it would cause some problem if we keep the text here in the categorical variables in the equations, because we would only want numbers in the equations. So that's why we need to encode the categorical variables, that is to encode the text that we have here into numbers. Okay, so in this tutorial we're going to encode these two variables, country and purchased, and you're going to see that the technique is quite different. So here we are on R. We're going to use something very practical in R, that is the factor function, and the factor function will transform your categorical variables into numeric categories, but it will see the variable as factors. And you will be able to choose the labels of those factors, and due to this specific reason, we won't need to create 3 columns for each category. We will just transform the country column into a column of factors, and we're going to specify what the factors are. So let's do this. Let's start by encoding the country column. So we just need to take the column country, and to do this we type dataset $country equals, and then we use the factor function, factor, and in factor we're going to specify 3 things. So let's have a look at the factor function. To do this we click on F1. Okay, so this contains some info about the factor function. Let's look at the arguments. The first argument is the data that we want to transform into factors. So this is of course going to be our country column from our data set. Okay. Then the second parameter is levels, and that's the names of the categories in our country column. So let's add here levels equals, so we're going to write the vector of levels here, C parenthesis, and then we will input here our 3 categories. So that's France, Spain, and Germany. All right. So by the way, C here is a vector in R. So by creating this C, France, Spain, Germany, we are creating a vector of 3 elements, that is France, Spain, and Germany. Okay, and the last argument that we need to input is labels, because we want to choose which number we want to give to France, to Spain, and to Germany. So we're going to add here labels. And then, since we transform our country categorical variable into factors, we don't really care what numbers to use. So let's use 1 for France, 2 for Spain, and 3 for Germany. So this has nothing to do with my preference. It's not because I'm French that I choose 1 for France. It is absolutely non-order relative. So it's just by default that I use 1 to 3. Okay, so that's it. I just forgot one parenthesis, and I think this should disappear. Yes, good. Okay, so the encoding of the country categorical variable is ready. It's actually more simple than in Python. So before selecting and executing this, let's look at our dataset. Our dataset contains our country written in text. And now let's select this, execute, and now let's look at our dataset. Perfect. Our country contains our encoded variable. And as you can see, 1 is France, 2 is Spain, and 3 is Germany. Okay, so that's all good. And now we need to do the same for the purchase column. And it's exactly the same. We're going to use the factor function. We're going to transform the text categories into numerical labels. So let's do it right now. We're going to copy this, paste it here. Here we're going to replace country by purchased. All right. Same for here. Here we need to change the levels because there are new categories. So the levels are going to be no and yes. Okay, and now of course we need to change the labels. So we're going to put 0 for no and 1 for yes. I think that's what actually makes sense. And parenthesis. Okay, and that's ready. Let's look at the dataset. The dataset contains no and yes in the purchase column. And now if I select this and execute, the dataset contains now 0 and 1. Perfect! We're all good. We encoded our categorical data in R, and now you know everything that there is to know about encoding categorical data in Python and R. So congratulations, we almost did the most difficult part. We are approaching soon the fun and exciting part about making models. So we are almost there. Hang on for 1 or 2 more tutorials, and this is gonna get very exciting. Okay, so we are almost done with part 1 data preprocessing. I can't wait to start making the machine learning models. We just need 3 more tutorials to make our dataset perfectly prepared before starting the models, and then we'll be good to go. Okay, so today we're going to talk about the fact that we need to split the dataset into a training set and a test set, and I'll explain why we need to do that right now. So let's go to Google Sheets. Well, I'm on Google Sheets, but you can be on Excel, you can be on whatever tool you want. But here is the dataset open with Google Sheets. So we have our 10 observations, and this is the dataset. This is the whole dataset. And what we should do in any machine learning models is that we're going to split this dataset into 2 separate sets, which are going to be the training set and the test set. Now, why do we need to do this? Well, when you take a step back and focus on the name machine learning itself, you understand that this is about a machine that is going to learn something. Well, here, it's your algorithm, it's your model that is going to learn from your data to make predictions or other machine learning goals. And so your machine learning model is going to learn to do something on your dataset by understanding some correlations that there is in your dataset. And imagine your machine learning model is learning too much on the dataset, like it's learning too much the correlations. Then I'm not sure its performance would be great on a new set with slightly different correlations. You know, it's like a student who is learning by heart his lesson, and then when he takes the exam, he might be in trouble because he learned too much his lesson by heart, and he does not manage to make the connection between what he learned and the exam. And it's the same for machine learning. We are going to build our machine learning models on a dataset, but then we have to test it on a new set, which is going to be slightly different from the dataset on which we build the machine learning model. So we have to make 2 different sets, a training set on which we build the machine learning model and a test set on which we test the performance of this machine learning model. And the performance on the test set shouldn't be that different from the performance on the training set, because this would mean that the machine learning models understood well the correlations and didn't learn them by heart so that he can adapt to new sets and new situations. Okay, so that's the idea about splitting the data set into a training set and a test set. And now let's do it on R. So here we are on R, the section is ready, splitting the data set into the training set and test set. And let's start coding the thing. Now that you understand well the difference between a training set and a test set, we're going to do it a little faster. So, new thing here. We have to import a library. We're going to import the library that is going to make a good split of the data set into the training set and the test set. And this library is called CA Tools. So let's import it. Here I'm going to the Packages tab to see the list of the libraries. Here you can see that the CA Tools library is here. I have it installed on the packages because I installed it before, but it's probably not the case for you if you're starting R for the first time. So we're going to install it. To install a library in R, it's very simple. You have to type install.packages and then in parentheses, quote, and then the name of the library in quote. So here we type CA Tools and we're ready to go. So then you have to select this line and press the Command or Control plus Enter to execute. Here it is, and right now it's installing the package CA Tools. Okay, perfect. So then you have to put it as a comment because you won't need to install it again. But then as you can see, we just installed the CA Tools library, but it's not activated yet. You know, it's not selected, and we have to select it. So to select a library, you have two choices. Either you click on the box here, as you can see this generates the script here, or, you know, if you have some scripts that you want to automate and execute once at a time, well, you can specify in your script that you want to include the library. And to do this, you just need to type library, parenthesis, and CA Tools, the name of your library, not in quotes actually, this time. Library CA Tools. Okay, perfect, and now you're ready to go. We can check. CA Tools is not selected right now, and if I select this and press Command and Control to execute, now it is. Now it's selected. Okay, so now we imported the CA Tools library that is going to make a good split of the dataset into the training set and the test set. So now let's make the split. So remember in Python, for those of you who followed the Python tutorial, we used random state equals 0 so that we get the same results. Well, here it's going to be the same. We're going to set a seed to have the same results, only we're going to do it now. We're not going to wait to be in the function in the library that makes the split. So to do it, we have to set the same seed, and so we can type set.seed, and in parentheses, we can choose any number we want. It can be this number, you know, that's a seed. If we both choose this number, we'll have the same result. But let's choose a more simple number. Let's choose, for example, 1, 2, 3. And now let's make the split. It's not as simple as in Python where we make it in one line. Here we're going to have to prepare the method that we're going to call split. That is the method that is going to make the split of your data set into the training set and the test set. Equals, and then sample.split. Okay, now if you want we can press F1 to see what we have to input. Okay, so see, sample.split, split data into test and train set. Let's see the arguments. The first argument is y. So that's not the same argument that we had to put for Python. In Python we had to put both the matrix of features x and the dependent variable vector y. Here we only have to put y. Only we're going to take y the following way. We're going to type dataset $purchased because your dependent variable is purchased. Okay, so that's okay for the first parameter. And then what is the second parameter? It's split ratio. Okay, so split ratio. Let's write split ratio here. And so split ratio is just a percentage of the observations that you want to put in your training set. So let's be careful. In Python, we put the percentage for the test set, and here we have to put it for the training set. So remember, in Python, we chose 20% for the test set. So here, logically, for the training set, we will choose 0.8. Okay, so what will this split return? So it will return true or false for each of your observations. That means that each observation will have either true or false, and it's going to be true if this observation was chosen to go to the training set, and false if the observation was chosen to go to the test set. So let's have a look. Let's select this. Command or Control plus Enter to execute. And here it is. We have the split here. So now let's go to the console and write split. All right, Enter. All right, you see that you have 10 values. And so true means that the observation goes to the training set, and false means that the observation goes to the test set. Okay, so now what we have to do is to create the training set and the test set separately. So we're going to do this. We'll type training set, which is going to be the name of our training set actually. Let's make it simple. So training set equals subset, parenthesis. And here as the first argument we put dataset, because the training set is a subset of the dataset. And here we will specify that we want the split equals true, and that's it. Okay, so that's it for the training set. Now let's copy this line, paste it here, and here we're going to change training set to test set, and of course we're going to change split equals true to false, because the test set are the observations for which the split equals false. And now we're ready. We are ready to make the split of the dataset into the training set and the test set. So let's execute these lines. Command and Control plus Enter to execute. And here we go. Test set and training set are created. Let's look at them. So let's click on the training set here and the test set. Let's move that here and that here. Okay. Let's look at the training set first. Okay, we see that we have 8 observations. Okay, good. And now let's look at the test set. Now we can clearly see that we have 2 observations with 6 and 9. Perfect. Okay, so that's it for this tutorial. You now know how to split your dataset into a training set and a test set. This is a must-do in any machine learning models. You have to test the performance of your machine learning model into a separate test set. So congratulations, now you are almost ready to begin the journey of making exciting machine learning models. We just have one thing to do left, feature scaling. You'll understand in the next tutorial why it's so important to do this. Almost final tutorial of the part 1 data preprocessing. I look forward to being well prepared with our data to start making our machine learning models. It's going to be very fun. We just have to hold on for 2 more tutorials and then we're good to go. Okay, so today we're going to talk about feature scaling, which is very important in machine learning. I'm going to explain you why right now. So I'm going to go to Google Sheets to find our data set, and here it is. Let's explain what is feature scaling and why we need to do it. Okay, so as you can see, we have these 2 columns, age and salary, that contain numerical numbers. Let's just focus on the age and the salary. You notice that the variables are not on the same scale, because the age are going from 27 to 50, and the salary is going from 40k to like 90k. So because this age variable and the salary variable don't have the same scale, this will cause some issues in your machine learning models. And why is that? It's because your machine learning models, a lot of machine learning models, are based on what is called the Euclidean distance. If you remember that back from high school, the Euclidean distance between 2 data points, between 2 points, is the square root of the sum of the squared coordinates. Well, actually here it's the same. We have 2 variables, age and salary. So you can picture age as the x coordinate and the salary as the y coordinate. And in the machine learning models equations, some Euclidean distances between observation points, for example this one and this one, are computed based on these 2 coordinates. And actually, since the salary has a much wider range of values, because it's going from 0 to 100k, the Euclidean distance will be dominated by the salary. Because for example, if we take 2 observations, for example this one, the 9th one, and the 3rd one, well, the Euclidean distance will compute the difference between this salary and this salary. So let's compute it. That's about, okay, so this minus this one. As you can see, this is 31,000. If you put that in square, okay, let's see, up, square, that gives this. And now let's take for the same 2 observations, the ages. So let's compute, equals 48 minus, it was this one, right? 27. Okay, that's the difference. And now let's take the square equals this square 441. So you can see very clearly how this square difference dominates this square difference. And that's because these two variables are not on the same scale. So, in the machine learning equations, it will be like this doesn't exist because it will be dominated by this. So that's why we absolutely need to put the variables on the same scale. That is that we're going to transform these two variables and they're going to have values in the same range. For example, they're going to have values from -1 to +1 here, and same here, -1 to +1, so that we don't get this sort of problem with a huge number here dominating a smaller number here, so that eventually the smaller number doesn't exist. There are several ways of scaling your data. A very common one is the standardization, which means that for each observation and each feature, you withdraw the mean value of all the values of the feature, and you divide it by the standard deviation. So that's the first type of feature scaling, and another type is normalization, which means that you subtract your observation feature x by the minimum value of all the feature values, and you divide it by the difference between the maximum of your feature values and the minimum of your feature values. Don't worry if you're not very comfortable with the mathematics here, but what you need to understand is that we are putting our variables in the same range, in the same scale, so that no variable is dominated by the other. Okay, so let's do it right now. Anyway, you're going to see how the variables are going to be transformed. You're going to see how they go from having large and very different values to small and same values. So let's move on to R. So here we are on R, and now that you understand feature scaling, let's apply it to the training set and the test set. Here we will just write two lines of code, which are, so the first line is training set. So the training set already exists, right? It's this one, the training set. As you can see, it's not scaled. It contains the raw values. So training set equals, and simply now we're going to write scale, and then training set. That's all. That scales your training set. Isn't it great? And same for the test set. We will copy this line, paste it here, and we will change training into test, and here as well. Okay, so here I just wrote this. There is something important to understand. This will be the feature scaling block of code that we will be using in our template. However, let's see what happens when I select this code and execute it. So let's select this, execute. Okay, as you can see here, I obtained two errors. Error and call means x must be numeric for the training set and the test set. Can you guess what the problem is? The problem is that, okay, well, it tells us what the problem is. It tells us that x must be numeric. But what does that mean? Well, first, what is this x? X is, for this line of code, the training set, and for this line of code, the test set. So let's forget the test set for a second and let's focus on the training set. So x is a training set, and it says that the training set must be numeric. So let's look at our training set. Okay, well, the training set looks numeric, right? Here we have numeric values, numeric values, numeric values, numeric values. But no, actually, there are two columns that don't have numeric values. It's this one, the country, and this one, purchased. And do you remember why? Well, it's because before we had the country written in text, and the purchase column written in text was yes or no, and we changed that by putting the categories as factors. That's what we did here, as you remember. Dataset country equals factor of the different levels and labels. And a factor in R is not a numeric number. And when you apply the scale here, x must be numeric. That means that all the columns in X, that is the training set, must be numeric. So this time we're going to exclude the categories from the feature scaling. We're not going to apply feature scaling on those columns. So that's very simple. All we need to do is to take the columns we're interested in, which are, well, the indexes of the column we want to scale, which are indexes. So indexes in R start at 1, so that's 1, 2, 3. So that's the second and third index we want to take to scale the age and the salary columns. So 2 and 3, let's input it. We need to specify here 2, colon 3. And that gets what we want. So now I'm going to copy this. Copy. Paste it here. Here. And here. Alright, and now it's ready. Let's have a look at the training set and the test set. So not scaled, not scaled. Let's go back to our code. Let's select this. And now we shouldn't get an error. Command and Control + Enter to execute. Here we go. It executed properly. And now let's look at the training set. All scaled properly. Perfect. And the test set. All scaled properly. Perfect. And now our data is ready to offer a good precision, a good accuracy, and a fast work of the machine learning models. And by that I mean that the machine learning models will converge rapidly. Okay, so that's it for feature scaling. Now you know how to apply feature scaling to your data in Python and R. Congratulations, and mostly congratulations because we did all the required steps to pre-process our data. Feature scaling was the last one because the next tutorial will be about this data pre-processing template, and I will just explain how we are going to use it in our machine learning models. It's going to be very fast and practical. So we are done with the data pre-processing. Congratulations, you did the most difficult part. And now it's time to have fun. It's time to start making the models. And I can't wait to start them with you. So thank you for watching this tutorial. I look forward to seeing you on the next one. And until then, enjoy machine learning.